G'day, this is just a quick video demonstration of a proof of concept switch mode power supply. What I've got built here is a buck converter topology on the right here. So we've got a switching MOSFET and an output filtering capacitor and inductor, and buried in there there's also a freewheeling diode, which you may not be able to see. But yep, there's a Schottky diode in there, freewheeling diode. Basically, I'm building this partly because I enjoy power electronics, but also because I want a 12 volt to 5 volt converter to run a Raspberry Pi off batteries. And obviously there's a whole stack of things you can get commercially, like you can go out and buy a phone charger that runs off 12 volts that'll run it, but I wanted to build something myself because I find this sort of stuff interesting. So we'll just do some quick tests here. The input voltage, you can see there is about 16 volts. This is just coming from a 12 volt plug pack that's unregulated, so the input voltage is fairly high there, mainly because it's a 1 amp plug pack and the output voltage of it floats fairly high when it's not loaded very much. Then the output is across these two 100 ohm resistors here, and if we put our probe there, we can see there's our bit over 5 volts. So the way this is working is I've got just a standard buck converter topology, and then the control is done over the left here. Basically all this is a voltage reference. We can see just got a 5.1 volt Zener diode there. So there's our Zener diode voltage reference. And this little chip here is just an op amp. I'm using a TL071 just because it was handy. And that's just set up as a hysteresis controller. So it's got some hysteresis in it, so when the voltage on the output drops below a certain threshold, it switches the MOSFET on, and then it doesn't turn off again until it's well above that threshold. And the hysteresis loop just reduces the switching frequency quite a bit. And I've got obviously some oscilloscope probes here, so we can pan over and look at the oscilloscope. What I've got is just the output voltage on this probe here, and just the gate drive, just because they look fairly interesting. So here's the crow screen. You can see the blue trace here is our gate drive, and that's peaking. I've got a gate drive circuitry on there, a high side circuit, and you can see all the schematics for this on my website, which I'll link down below. But that's peaking probably about 12 or 13 volts over the supply rail. So what's that? 5, 10, 15, 20, about 25 volts it's peaking at, just to drive the high side N-channel MOSFET on. And this ripple down here is our output. So you can see when the MOSFET switches on, our output rises, then it slowly drops. And if you're interested, this one of the nice things about the controller I'm using is that the switch mode power supply quite naturally runs in discontinuous mode. We can just swap the probe here. Okay, what I've done now is just got the probe across the freewheeling diode. So this peak on the left here is when the MOSFET switches on, so the voltage across the freewheeling diode jumps up to our supply rail. Then when the MOSFET switches off, we get this negative part here. This is about negative 0.5, and that's just when the freewheeling diode is conducting. And eventually the current in the inductor completely dies off and the diode switches off, and we get this bit of a ring here. But that basically rings down to 5 volts, which is our output voltage, which is what you would expect if there was no current in the inductor and the output was 5 volts. So that's a nice proof of concept. Schematics are on my website, and I'll be building this in the coming weeks onto a proto board so I can power my Raspberry Pi off it. Hopefully this has been interesting.